Hello, welcome to the ITGilde Tech Talk series, and today's topic will be on-premise website failover to AWS using Route53. Who am I? My name is Hans Veringa and I'm a freelancer. I'm a member of ITGilde. I joined ITGilde in October 2014 and I was assigned the member number of 5. That made me think about this guy, Johnny number 5, input. Anyway, as mentioned, we're going to talk about Amazon Web Services, Route53, and in particular the on-premise website failover to AWS using this service. The quote that you see below, "Everything fails all the time," is a quote from Werner Vogels, CTO of Amazon.com, and is an important concept behind AWS. AWS was built for failure. Well, what's the agenda for tonight? Who am I? Well, that part of the introduction we already covered. Next, we're going to talk about the AWS locations and then the services we are going to use within AWS. We will be explaining our demo environment with our very simple on-premise website, which only serves as static content from the index.html file. We will set up the virtual private cloud, or actually I already did that to save some time for the demo. Set up the EC2 instances, configure the load balancer, and do the configuration of the Route53 service. And since we are using our own domain, we will have to delegate a subdomain to AWS. Once that's done, then we'll have a demo to see how things are actually behaving. First of all, the AWS physical locations. We need to talk about the regions and availability zones. Regions are the kind of the top level designation for physical locations, and these have availability zones that are the actual physical locations, like data centers that are geographically apart. Example for the regions, and this is actually the region we are going to use. Use our demo in is the EU West 1 in Ireland. A region has, as I said, multiple availability zones, which are multiple data centers that are connected with low latency links, and each region has a number of availability zones, and the number actually depends on the region you're working from. The minimum is of course 2 availability zones for redundancy reasons, but there can be more depending on the region. Currently there are 14 regions across the world, and we are working from the EU Ireland region. The availability zones are part of a single region, and they are on different physical locations for redundancy reasons, and as I said, they're connected via low latency links to work like they are in a single data center. The AWS services we will use. AWS has an enormous amount of services, and we're only using a very small fraction of those services to create this demo. One of the things we need to do is set up our virtual private cloud. And a virtual private cloud is kind of your own private data center in the AWS cloud, and it's living in a single region, so it doesn't span multiple regions. It's a virtual network or networks dedicated to your AWS account, and when you launch your resources in your VPC. As mentioned before, a region has multiple availability zones, and a VPC is part of your region. So a VPC has the availability zones that are part of that particular region, and it spans all those availability zones in the region. If you create your VPC, you need to define some stuff like your range of IP addresses you want to use, the subnets that are part of that CIDR block of your VPC. You need to have security groups. Actually, we're going to create only a single one. Routing tables. You need to have an internet gateway. We're not going to use the NAT gateway, by the way, but I kind of added this for completeness, because further on we'll show some examples where you want to use the NAT gateway. Access control list, that's one of the things that we need to define, and are also kind of firewall type rules like the security groups. Number of availability zones in a region depends on the region itself. This one is for US East 1, has 6 availability zones, but the availability zone the region we are going to use has only 3 availability zones, and there are a number of regions that only have 2 availability zones, and one such region is Asia Pacific South 1. That's only 2 availability zones, which is a bare minimum for redundancy reasons. The example VPC. Let's zoom in a little. If that's possible. Yep. This is the default VPC. We are not going to use default VPC, but this is the example that you get. This is the default VPC. And it shows you the different components in the VPC. The region as the outer layer. Within that you have your default VPC, and within the default VPC in this particular example you have 2 availability zones, availability zone A and B. Each of them have a single subnet defined, and that's the default subnet that comes with the default VPC. The main VPC CIDR block is 172.31/16, and the subnets are /20 subnets. So the first one is 172.31.0.0/20, and the default subnet 2 is 172.31.16.0/20. Both have a single instance configured in this example, and what you see is 2 IP addresses, a private IP address and a public IP address, both of them IPv4 IP addresses, and a single routing table. The single routing table defines a destination or local for everything that lives within the VPC CIDR block, to be able to route between the different availability zones. And we have the default gateway is an internet gateway resource as defined here. This internet gateway is doing a one-to-one NAT for all the instances that have a public IPv4 address mapped to it, as you can see. In one of the other examples that we are going to see, let me zoom out a little, we'll see that there is also a private subnet that is not routed via the internet gateway that uses one-to-one NAT, but via NAT gateway, as I mentioned before. And these devices that have only private IP addresses don't have mapped internet public IP addresses. So this is what I explained. VM has a public address dynamically allocated and mapped to the instance. But if you look into the VM itself and ask for a listing of the IP addresses locally, you'll never see the external addresses. It only is aware of its private addresses. And VM can also be configured to don't have mapped public addresses. We'll see that later in the next diagram, where we have two subnets, where one subnet is what they call a public subnet with instances, web services in this case, that each have an elastic IP address mapped to it, and database servers, which are backend servers that there's no need to have direct connection from the internet to them, and they live in a private subnet. The private subnet is associated with the main route table, and the public subnet is associated with a custom route table. In addition, you'll see here a net gateway instance, a resource with an elastic IP address. Everything in the public subnet is routed through the custom route table via the internet gateway using the one-to-one NOT function. On the other hand, you have the private subnet that is handled by the main route table, and you'll see that the default gateway for those connections go via the net gateway. The net gateway has a single IP address, so it's only for connections from the database service to the public internet, for instance, for updates and stuff like that. Routing tables, well, we explained most of it already. Either a main or a custom routing table, or both. Routes for the internal VPC traffic, so between availability zones. Routes to the internet gateway we have seen, routes to the net gateway we have seen, and there can also be routes to other destinations. For instance, if you have a VPN between your on-premise data center into the AWS cloud, you have a VPN endpoint, and that can be one of the other destinations. And then you specify your destination setter block that lives in your on-premise data center, and you have the target for your VPN endpoint there. And also, also important, of course, the association with the subnets that this routing table is working for. One of the things is that once you create a subnet, if you do nothing, they're implicitly associated with the main routing table. In this diagram, it's schematically shown how you associate them. There's in step by step, you associate a subnet to the custom route table, then it will be automatically removed from the main table, and eventually you either have the situation where you have both, or only the custom table, and in the last part you even have can have that you dispose of the default route table. But all of those will will have a valid configuration depending on your needs, of course. This is something we've seen. So for the routing table to the internet gateway, we route the default route is into to the target internet gateway, and for the NOT gateway, it's to the NOT gateway resource. fairly simple. The Internet Gateway provides a target, so you define it as a target, as an ID for using your routing tables. And it does, as I said, I mentioned in one of the earlier slides, that it does the one-to-one net, so that each EC2 instance has its own private IP address on the outside. On the inside it has its private IP address, on the outside it has its public IP address. And Internet Gateway supports both IPv4 and IPv6, and for our purposes we only use IPv4. Security groups. Security group is a virtual firewall. This firewall is kind of attached on the outside of your instance. It's part of the AWS infrastructure, and as such you don't see it in the in the EC2 instance itself. So it's apart from the IP tables you can run in your own host, but it's similar, and you can attach it on an instance. So multiple instances on the same network can have different security groups depending on the needs. And importantly is that security groups are stateful, so you don't have to take into account when setting up your rules for return traffic. That's implicit. Access control lists, on the other hand, are stateless. These are stateful. These are stateless. So you need to address that in your rules, that you will allow return traffic either for outbound or inbound traffic, and it's not working on the instance level, but it's working on the network, the subnetwork level. So you define access control lists for all instances on that particular subnet. The EC2, that's your virtual server, the instance, and it's built from the Amazon machine images. If you launch that and you specify a specific type, it will build that and configure that from the Amazon machine image that is prepared specifically for that purpose, and it's using Cloud Init to configure it. One of the things that Cloud Init will do is inject your SSH public key into the instance, because you cannot use password authentication. You need to use SSH key, so you have to prepare your configurations in such a way that you can attach the SSH key to the EC2 instance. Then we have an elastic load balancer, because that is that's going to be our target in Route53. Your failover target. It will be failing over to the elastic load balancer. It provides a single point of contact for your clients. It will not be directly used, although you can. I mean, it has a URL, and you can use that and talk to the load balancer even directly, even if there is no situation for failover at the moment. It has listeners. It listens for certain connection requests, and the connection request we're going to use is only HTTP. It distributes traffic across multiple targets being the EC2 instances that are in the target groups, and it monitors the health of registered targets. So once target is no longer available, it will not try to distribute traffic to it. There are two types of load balancers. A more recent one is the application load balancer, and the classic one obviously is the classic load balancer. And for our purpose, it doesn't really matter which one we are using. In our demo, we'll be using the application load balancer. Then Route53. The service routing and DNS service of AWS. It routes end users to internet applications using manipulation of IP addresses for a particular resource record. We need to set up a hosted zone for that, which is actually a domain definition with name servers, name server records, and other types of resource records. In our situation, we are going to use a subdomain for the hosted zone, so we need to make sure that we have a subdomain delegation set up at our provider, so that the subdomain is delegated to AWS. We specified resource record for the primary and for the secondary, and we have to set the failover policy, and we have to define our health check that will trigger a failover once the main on-premise web server is unavailable. And the hosted zone has 4 name server records initially, and the start of authority records, and then later on we have to add our own resource records, primary and secondary, in our demo, as we will see later. This is the health check that we saw before. As I said, we're going to monitor the on-premise web server, so it's not the one with the subdomain. And we're going to delegate a particular subdomain. Well, we'll see that later on in more detail regarding the specifics of our demo. And now we come to the specifics of our demo configuration. Our on-premise website is a very simple static type hello world HTML file, an index.html file with some text that will show that it's coming from the on-premise website. The EC2 instances have slightly different texts to make them stand out once we have a failover. Subdomain is our main domain that we're going to use is cloudguru.nu, and from that main domain we have a delegated subdomain, ITGilde, and if we are going to communicate with our web service, then we're going to use the AWS ITGilde.cloudguru.nu. Our VPC, the VPC that I created before, otherwise it will take too long in our demo, has a CIDR block of 1010/16, and from this we will create our subnets, or already did that, of course. We have in EU West 1, we have 3 availability zones, so I created 3 subnets in the availability zones. The availability zones are 1A, 1B, 1C, or actually A, B, and C, of course, and I gave the subnets similar names. You see that on the left-hand side as the names of the subnets. The subnets are /24s from the 1010/16 CIDR block from the VPC. I created 3 of them, as you can see here: 1010/1/24, 2/24, and 3/24. Now only using the 1A and 1B subnets for our demo purposes. The routing table, fairly simple. It has a local and default gateway entry for destination. So the local is for the 1010 network, so that the availability zones are reachable from either end, and everything else goes out via the internet gateway. Of course, we have to associate the subnets with this route table to be able to work with this routing table. Security groups, similar. We have the inbound rules. For our demo, only the first rule is of really importance. If we want to log in, we have the SSH stuff that I use to configure those EC2 instances, but for our demo we only use HTTP traffic. And outbound, everything is allowed, and remember, this is stateful, so we don't need to do anything for return traffic. See, it's only allowing a particular inbound rules and allowing particular outbound traffic. That's about it. Access control lists, on the other hand, we have to define the rules for return traffic. If you have a look, and I'll zoom in a little, rule number 600 has a custom TCP rule for the return traffic of outbound traffic. And if we go to the outbound rules, then we have rule number 500 for the return traffic for the inbound traffic. And also remember, ACLs work on the subnet work level, so they work for all instances on that particular subnet, while if you have security groups, you can have multiple security groups that you can assign to a particular EC2 instance in the same subnet, and they only work on the instance level itself. And of course, we need to associate the subnets we are using to this particular ACL. An elastic load balancer that has a listener, of course, for the HTTP traffic. It monitors the endpoints for its health, and these endpoints are configured in a target group, and we are using two EC2 instances in two different availability zones. As I said, I have one instance in availability zone 1A and one in availability zone 1B. Configuration of Route53. Well, we created the hosted zone, and the hosted zone is a delegated subnet. If we create the hosted zone initially, this is what you will get. 4 name server records and a SOA record. We need to have copy those name server records and use them at the DNS configuration utility for the provider for our main domain name. If you have to configure this, you have to take into account that it will take a day or even more before everything is propagated through the entire internet. So I already did this a couple of days ago to make sure that everything is propagated. And this is how I configured it as a delegation. I have the left side ITGilde as the name of the record, and the type is a name server with the name server name as a value. as the value of the resource record. And this way we have delegated ITGilde to AWS to those 4 name servers. The 5 minutes in the NS had nothing to do with the regular delays that NS has, which is the railway in the Netherlands. It's nothing to do with that. Anyway, the health check, we've seen that before, so we can kind of skip that unless there are some questions about it. And then we are going to create our resource records. We are going to create 2 resource records. That's a primary record with a health check evaluation, and it has a failover policy, and a secondary also having a failover policy, but that's our target for the failover. The primary, I'll zoom in a little bit, is the name of the record set is www within the hosted zone, ITGilde.cloudguru.nu. It's an A-type record. It's not an alias. An alias, you're going to define it in the secondary, you'll see later. And the value is an IP address. You can have multiple IP addresses if you on separate lines, as you can see in the example below. In this case, we only have a single IP address, no round-robin stuff going on there. The routing policy is failover, and the failover record type in this case is primary. And we need to associate it with a health check, as you can see here. And the name of the health check that was defined before. The secondary resource record has also the same name, and in this case we say it's an alias. Once you say it's an alias, you get to select a resource within AWS as the target. As you can see below, there are several types of targets available. In this case we'll use the Elastic Load Balancer DNS name as target. The routing policy is also a failover, and in this case the failover record type is secondary, and we do not use the evaluate target health or associate with health check. Optionally, there is some alarm email that you can have yourself send when when there is a failover event. There is an alarm, and you get this email that your primary website is down. This is actually coming from the region US East 1, and I think it's the main region, and because it was a little bit confusing, because it said that it was failing in my ITGilde test page was failing in the US East North Virginia region. So I think it has to do with the fact that some of the services are very centrally managed, or I would say made available, and maybe this one as well. I didn't look into it further, so I left it at that. I know that this text had to do with our demo. And then it's time for our demo. I'm going to pause the video for a while and set up the screen for the demo, and then we continue from there. So we're back from the break. I set up my screen. In the bottom we see all the configuration screens of AWS we're going to work with. On the top I have some terminals with some information. In the top part we see that the www.ITGilde.cloudguru.nu has this particular address, and this is the information we retrieve from the index.html file. In this part, lower right part of this terminal screen, we see that what IP address it's associated with, and in the left bottom of the terminal screen we see the index.html file that we are going to manipulate permission wise, so to introduce an error state that will make the failover happen, that it will trigger the failover. I already created two EC2 instances that we will start up for this demo, and I really want to start them. Yes, thank you. And then I want to show you that we have already a target group defined. In the target group, we get a refresh. The targets in this target group are those two instances we just saw. They live in the availability zones EU West 1A and 1B, and currently they are unused. We currently have no load balancer configured. That we are going to set the load balancer up in a minute. This is the health check that we defined before. I defined that some time ago, so you can see that it has been in a healthy state for at least a day. And we have health checkers around the world. You can see them here from all regions. Each region has a designated health checker IP address that will report about the status of the resource. And this is the hosted zone that we created, the ITGilde.cloudguru.nu. And if we open that, then you will see that I already have a primary record defined for my on-premise website. I'm not going to change that because it's quite clear what the configuration is. I can show you that there are more routing policies that you can choose from. We are working with a failover routing policy at this time, and the other ones have to do with other kinds of decisions based on which the routing is done. Weighted, for instance, has something to do with that you can define a particular weight on a particular target, and then it will either give it more traffic or less traffic depending on what you the ratios that you define there. Latency, depending on the latency for a particular target. Geolocation, so depending on where you're coming from, if you're coming from Asia Pacific, you will be routed to a target that is geographically near you, depending on how you configure it, of course, and then you have multiple regions that you have to work from. So this is what we keep, but before we are going to go into configuring the secondary resource set, we need to first have a load balancer, because the load balancer is going to be our target for the secondary resource set. As I said, we're going to use the default application load balancer, and we're going to continue. I'm going to give it a meaningful name, it has already the HTTP listener configured, so I don't need to add any more. I'm not going to use the default VPC. I'm going to use the VPC that we created for this specific purpose. Let's just use these two because I don't have any. I want to show you this. If I only use this one and I want to continue, it says that you at least need 2 subnets to be specified. So a load balancer needs at least a configuration with 2 availability zones. Even if you don't have anything in that other availability zones, it will ask you to do that. So we go to the configure security groups. Before that, it will give me a warning that I don't have any secure listeners like HTTPS, for instance. Well, that's fine because we are not going to use that. Then we are going to select an existing security group. The security group was already configured during the creation of the VPC. We're going to do the routing. The routing has to do with how the load balancer will route traffic to the instances that are part of the target group. So, and I already have a target group, so we're going to use that one. And we'll see that we don't have to do anything here because the targets are already registered because they were part of the target group. And then we can review the configuration and see if everything is okay. Looks good. And then I say, okay, let's create that. Load balancer created successfully doesn't mean that it's already there, because if you look here, it says it's still provisioning. But I'm interested in this, so we can use this to configure our. I'm going to copy that one. We're going to use that to configure our secondary record set. So I click create record set here, and the name is www. I want this to be an alias. You can either select it. Well, it doesn't have the application load balancer yet. This is one that I used before, and this is in a test, and this is in US East 1, and we're working from EU West 1, so that's not available here, and that's not the one we're using. So I'm going to copy the DNS name of our load balancer in there. I'll set the routing policy to failover and say that the failover record type is secondary. Create it, and then we'll see we have the record set. What we do now is I'm going to trigger a problem here by changing the permissions on the index.html file, that it is root owned and can only be read by root. The problem is that we now see that the status is a 403. It's forbidden. If we look at the health check, it's still healthy, no problem here. The health checkers did not, probably not detect that something is wrong. Next interval that they will check for the health of the particular web server, this will change, and eventually when all health checkers say, well, it's no good, then it will switch over, and you'll see that in those two windows, on the left on the top and on the right bottom in this terminal window. If I refresh this and have a look again, it's still success. That's HTTP status code 200 OK, and the resolved IP address is OK. Oh, come on, refresh it again, and see. And then we see that some of them already have detected that there is a failure, and eventually it will trigger a switch over, which you will see in this terminal window on the top, and you'll probably see that immediately on the right hand side down here that the IP address has changed. That's the mechanism to route traffic to a different IP address. Let's have a look again, see if refresh what the current state is. Oh well, it's already oh great, I have a service temporary unavailable. So yeah, I think I know what is the case. Did we have working? Well, this is the problem. The instances did not really start, so I want to start them. I don't know why they didn't start, but it means that they are routed to the instances, and none of them were actually working. So I thought I had started them, but probably I had the intention and I didn't do that. So we have to wait a little while until the status is okay. And there you see that at least one is okay, and I have a single IP address that is different from the one we had before, and I see this should be alternating between the one and the other EC2 instance. That means that one of them is still kind of initializing. Yes, and now it's available. Then you see that that it's alternating between one and the other, because the index.html has a slightly different configuration. So what we are going to do now is we want to see that it also can switch back. So we're going to change this again to be readable again. So it's readable again. So eventually the this one I need. This one is, by the way, should now indicate that it's unhealthy. I didn't show that one yet. I had to refresh it. I'm going to refresh this one, and those are all in failure. So eventually this will change again to healthy states. I see now, by the way, 2 IP addresses. That's what I expected, and you see it kind of round robin like thing. Then one, then the other. So that shows that there are multiple load balancer entities working for you. Where is my window? Here, refresh it again. My guess is that, yeah, well, some of them already have detected that it's healthy again. I see they're all, well, except one. That will probably change within a few seconds. and then it will trigger a failback. Yeah, and now you see that there was a failback. The address has changed. I still have this one. That depends on this is on a different computer than on this one, and you'll see that now gradually it will change to the right address. And we're back on our on-premise website. This will mostly be behind a few seconds to a few minutes before it will show here that the status has changed back to healthy. See here, that's not the one I was looking for. I was looking at this one. It's a bit small, this window, but and in the end it will show that everything is okay again. You see here that it came from 100% healthy to gradually, this is 21, and this is 80%, and probably it's already back to healthy. No, not yet. Oh, I need to check that one. And you see here, I guess this is 100%, right? Yep, it's back to 100%, so I would guess that this one is also healthy again. Yes, it is. And that is the end of our demo. Thank you for watching, and perhaps till next time.